Hey guys, welcome to day 3 notes of acids and bases. So for today's notes, we are going to calculate pH and other hydrogen and hydroxide concentrations. So first off, just to review just a tad bit, remember that our pH scale ranges from 0 to 14, 0 being strongly acidic and 7 being neutral, and then 14 being strongly basic. Okay, so to find the pH of a solution, this is the equation you're going to use right here. So to find pH, you are going to use the negative log of your hydrogen ion concentration. Okay, so you won't be able to determine pH without having a hydrogen ion concentration. Okay, so on your calculator, okay, just look for it really quick. Where is your log button, LOG? Okay, and then it's also really important that you use the negative sign or the negative button, not the subtraction sign. Okay, you'll get an error in your calculator if you use the subtraction sign instead of the negative sign. Okay, so once you find that, we'll go ahead and perform some calculations. Okay, so really quick, before we even do any calculations, there is a trick that I want to show you. You'll be working harder and not smarter if you don't listen. Okay, so as long as you have a 1 times 10 to whatever power, then the pH is the exponent. Okay, so if we take a look at these following examples, okay, they all start with 1 times 10, 1 times 10, 1 times 10 for our hydrogen ion concentration. So then that would mean the pH for A is going to be a pH of 2. Okay, and again, if we have a pH of 2, it's going to be an acid. Okay, so if you want to try to figure out what the rest are on your own, go ahead and pause it right now, and then just play whenever you're ready. Okay, so for B, if we have 1 times 10 to the negative 9, then that means our pH is going to be a 9. And of course, since it's because it's above 7, then it would be a basic solution. And then lastly, C, 1 times 10 to the negative 5, that would mean we would have a pH of 5. And it's because it's below 7, it would be an acidic solution. Okay, now what happens if it's not 1 times 10 to the whatever power? Okay, so this is where you're going to start to use that formula. The pH equals negative log of your hydrogen ion concentration. Okay, so if our hydrogen ion concentration is 2 times 10 to the negative 2, then in your calculator, you are going to put the negative log of 2 times 10 to the negative 2, and then close parentheses. Okay, and then your calculator should tell you, hey, your pH is 1.7. Okay, so go ahead and take a second. Go ahead and pause the video. Try to practice doing A. Let's see if you get the same answer I did. And then go ahead and do B as well as C so we can see if you get the same answers as well. Okay, so go ahead and pause it right now and then push play whenever you're ready. Okay, so for B, the negative log of 6 times 10 to the negative 9, we should get a pH of 8.2. And then for C, the negative log of 3 times 10 to the negative 5, we should get a pH of 4.5. Okay, hopefully this is not too difficult. All you're doing is just pushing negative log and then your hydrogen ion concentration to find pH. Okay, so we do have 2 more formulas that we are going to discuss today, and that first one, or actually it's the second formula. Okay, the second formula we have for today is pH 14 equals pH plus POH. If you remember from the other day, notes day 2, pH stands for potential for hydrogen. So POH would stand for the potential of oxygen. Now remember, they are kind of, they have an indirect relationship. So if we have a high concentration of hydrogen, that would mean we have a low concentration for hydroxide. And remember, if the constant for water equals 14, so when you add these two together, it should equal 14 as well. Okay, and we'll take a look at our example for this equation in just a second. Okay, so again, the equilibrium constant labeled as Kw, or the constant of water, is 1 times 10 to the negative 14. So again, if you have your hydroxide ion concentration and multiply that by your hydrogen ion concentration, it should equal 1 times 10 to the negative 14th power. Okay, so Kw is essentially just an equilibrium constant for the reactions shown. You may meet it in two forms based on the fully written equilibrium. Kw equals hydronium times hydroxide, or simplified, or on the simplified equilibrium, Kw equals hydrogen ion times hydroxide ion. You may find them written with or without the state symbols. Whatever version you come across, they all mean the same exact thing. Okay? So, oh no, I kind of gave you all the answers already. So let's just go ahead and explain what is our problem first. Okay, so what is the pH of a solution with a hydroxide ion concentration of 4.0 times 10 to the negative 11th power molar? Okay, now it's asking for a pH, and it's given us your hydroxide ion concentration. Well, if you remember, the only formula that has the hydroxide ion concentration is our Kw formula, which is this right here. Okay, so this is the only formula we can use with this given. Okay, so if we plug in our given into our formula, we end up with 4 times 10 to the negative 11 times your hydrogen ion concentration equals 1 times 10 to the negative 14. And of course, to get our hydrogen ion by itself, we would simply divide both sides by 4 times 10 to the negative 11. And when we divide that, we would get a hydrogen ion concentration of 2.5 times 10 to the negative 4. Okay, so now that we have a hydrogen ion concentration, we can simply plug this into our negative log formula, which will give us the pH we are looking for. Okay, so the negative log of 2.5 times 10 to the negative 4 equals 3.6 pH. Okay, so this is honestly the extent of how difficult this can be. It's going to be a two-step problem. Okay, you're going to be given a concentration, but then, and this will be the only formula you'll be able to use, and then you'll have to use a second formula to try to figure out what it is that it's asking for. Okay, so 2 steps is really the farthest or the hardest it'll ever get. Okay, so let's go ahead and take a look at a few more examples. Okay, so if pH equals 5, what is your pOH? Okay, so take a second to think of, out of the 3 formulas that we have, which formula would you be able to use? Okay, so if it's asking for pOH, there is only one formula that has pOH. So if we simply plug in what we've been given, which is a pH of 5, if we plug that in, we can solve for pOH. So 14 minus 5, we would get a pOH of 9. So because we have a pOH of 9, what would you consider this solution? What type of solution would you consider this to be? Okay, do you consider it to be acidic, basic, or neutral? Okay, you would actually consider this a acidic solution. Okay, you don't even have to look at pOH, because remember, pH is acidity or alkalinity is based off pH. And since our pH is below 7, we automatically know that it's going to be an acid. Okay, so sample problem number 2. So what is the pH of a solution that has a hydrogen ion concentration of 1.0 times 10 to the negative 5 molar? And second question, is this solution acidic, basic, or neutral? Okay, so go ahead and take a second, pause the video, try to figure it out on your own, and then play it when you're ready. Okay, so if you said that you don't use any of those formulas, you are correct. Okay, if you remember in the beginning of this video, I told you guys that there is a shortcut. Remember that your hydrogen ion concentration, if you're trying to look for the pH and your hydrogen ion concentration starts with 1 times 10 to the whatever power, that exponent is your pH. So without even doing any kind of math, you would automatically know what your pH is. But if you did say that we are going to use the negative log formula, you are also correct. Okay, but it's just an extra step that you really didn't have to do because you would still get a pH of 5. And because we have a pH of 5, then our solution is actually an acid. Okay, so question number 3, what is the hydrogen ion concentration of a solution with a pH of 11? And then our second question, which has a greater concentration, hydrogen ion or hydroxide ion? Okay, so again, pause the video and then play it when you're ready. Okay, so again, this brings me back to the beginning of the video. Okay, if your hydrogen ion concentration is 1 times 10 to the whatever power, that exponent is your pH. Okay, well, it also works the other way around. If your pH is an 11 and you don't know your hydrogen ion concentration, we'll just stick it into that generic formula. So our hydrogen ion concentration is 1 times 10 to the negative 11 molar. Okay, and then if you look at the pH, your pH is 11. It's telling you that you have a basic solution. So you should have more hydroxide ions than hydrogen ions. Okay. Question number 4, what is the pH of a solution that has a hydrogen ion concentration of 1.2 times 10 to the negative 8 molar? And is this solution acidic, basic, or neutral? So try to figure it out on your own. Push play when you're ready. Okay, so our hydrogen ion concentration is not 1 times 10. Okay, it's 1.2. So that means the formula you should have picked was pH equals the negative log of our hydrogen ion concentration. So when you plug that into your calculator, you should have got 7.92. And because it's greater than 7, you know that this is a basic solution. Okay, and then lastly, number 5, assuming that your constant for water equals 1 times 10 to the negative 14, calculate the molarity of your hydroxide ions in solutions at 25 degrees when your hydrogen ion concentration is 0.2 molar. Okay, so again, try to figure this out on your own. Whenever you're ready, push play. So the good thing about this problem is that it kind of already gives you a hint as far as which equation to use. Okay, it already tells you that the constant of water is 1 times 10 to the negative 14. And it's asking you for the molarity of your hydroxide ion concentration. Okay, and then it also gives you your hydrogen ion concentration. So if, again, the only equation we can use is the KW equation. Okay, so when we plug in everything that we've been given, okay, and we rearrange our equation around, we would be dividing by 0.2. So 1 times 10 to the negative 14 divided by 0.2, and you guys should have gotten 5 times 10 to the negative 14 molar. Okay, and also one last thing, the 25 degrees, it is just there to distract you and throw you off. Hopefully it didn't. Okay, the only thing you really needed is your hydrogen ion concentration, what your unknown was, and then that little hint of which equation to use. Okay, so that concludes our notes for today on how to calculate pH as well as your hydrogen ion and your hydroxide ion concentrations. If you have any questions, please feel free to comment or ask me in class. Y'all have a good one.